Hello everyone. Today I'm going to be talking about GODSAC star, which is graph optimized DSAC star for robot relocalization. In mobile robotics, the kidnap robot problem is when a robot is instantly moved from one position on a map to another. In order to relocalize, the robot cannot rely on a history of past measurements. The question then becomes, how can it use the images of its surroundings to get the current position? Different cameras have their advantages and disadvantages. RGB cameras have an outstanding resolution at a low price. The alternative are depth images, which can be more expensive to collect but provide more information for relocalization. Our solution to the kidnap robot problem is GODSAC star. So GODSAC star takes in a sequence of RGB images, and using DSAC star, it translates that into a pose estimation for the camera. Then it integrates odometry using GTSAM, and using graph optimization, it returns a trajectory based on the RGB and odometry combined. The dataset that we're using is the U of M NCLT dataset. And in this dataset, it contains ground truth 6th-off poses, RGB images, which can be seen on the right, and the odometry data. All this data is collected by the robot pictured in the center of the slide. So DSAC star is a learning-based solution for pose estimation. After being trained on the NCLT data, the DSAC star is able to estimate the camera rotation and translation from a new image of the same scene. To train DSAC star, it consists of two different stages. The initial stage, we ran 1.5 million iterations, and the training loss for this can be seen in the top right. We ran 100,000 iterations on the end-to-end stage, which is more fine-tuning of the weights in order to repredict the pose of the camera. So we tested DSAC star against another robot relocalization framework called PoseNet. And by the results shown at the bottom of the slide, you can clearly see DSAC star provides a better rotation error and a better translation error compared to PoseNet. GTSAM is a C++ library that implements smoothing and mapping. And we use the GTSAM's implementation of ISAM2 for graph optimization. And this is all implemented in C++ to reduce latency, but the rest of our project is written in Python, so we use ROS to provide the communication between everything. And here are our preliminary results. In the table, you can see the translation root mean squared error is pretty low for DSAC star on its own at 12.3 meters, but GODSAC star with the graph optimization reduces that even further to 9 meters. And on the right, you can see plots of what I was just describing. The top is DSAC star only, and the bottom plot is after graph optimization. Comparing this to PoseNet++, which is another end-to-end robot relocalization framework, and you can see they're getting results of 20.4 on the NCLT dataset. Here are our results visualized in RViz. On the right, you can see the estimated pose of the path taken from the images on the left. And we chose this because of all of the turns that the path is taking. And you can see the pose still is providing a reasonable estimation despite all of these turns. In the future, we would like to test our solution on more difficult data sets and maybe even use depth prediction to provide some depth images and also test out different neural network architectures. Thanks for listening, and you can learn more at our GitHub page.